Okay, we're going to continue to look at a sequence. Remember, when you're talking about a sequence right here is just a list of numbers. So, for example, you could say 2, 4, 6, 8, and you could continue this. This is just a list of numbers, okay? For it to be an arithmetic sequence, now you're talking about it has to have a common difference. So this is going up by 2, this is going up by 2, and this is going up by 2. Notice it's changing by 2, so it has a common difference. So that is an example of an arithmetic sequence. When we did our marshmallow explorations, both days, you had a graph. And when you graphed them, for example, it looks something like this. Okay? Hopefully you're realizing that is the shape of a line. And you'll notice since it's points, it's also discrete. So that's what we're talking about when we're talking about an arithmetic sequence. It's going to be linear and it's going to be discrete. The reason it's linear is because that's what that common difference says. It's that constant rate of change. We've got two formulas, and I know they look very overwhelming. One is called a recursive formula and one is called an explicit. I want to focus on a recursive formula. Here would be an example of a sequence, okay? Pause for a minute and see if you can figure out what that next term would be. So if you looked at it, the next term would be 21. The one after that would be 13 plus 21, which would be 44, and so on. All that's happening is you're adding the two previous numbers. This is 2. Notice, you get 2 next. Then you add these 2 to get 3. Notice, that's what's next. So basically what you're doing is you're adding the two previous numbers to get the next number. That's kind of an example of what the recursive formula does. It always has to have the previous. So for example, this part of our equation right here is actually saying take the previous number, and this is saying add the common difference. Okay? So let's label our little f of n. That's in the exact same place as y. So that's just any of your y answers. That's all it is. It's just an answer. The f of n minus 1 is going to be the nth term in the list. Okay? That's just your n value. I'm sorry. That's what the n represents. So if I'm wanting to find the 5th term, then n is going to be equal to 5. If I don't know what n is, then I just refer to it as the nth term. And d is going to represent that common difference. Also known, you're familiar with constant rate of change, those same type of ideas. Okay? We're going to go ahead and put this recursive formula to use. So I'm going to write it right here, f of n. Now this is just a basic formula for everything. We're going to make this formula personal to this sequence. First of all, let's decide if this is arithmetic. To go from 2 to 11, I would add 9. To go from 11 to 20, I would add 9. And to go from 20 to 29, I would add 9. Since these are all the same, the common difference is 9. That list of numbers is changing by 9. So it is an arithmetic sequence. Okay? If I want to write the recursive formula, the only thing I'm going to replace is the d value. So my recursive formula for that sequence would be plus 9. That's all I have to change. What I want you to think about is this right here says take the previous term, right? So let's see how that works out. They want us to find the 5th term. That means n equals 5. So f of 5 equals f of, if n equals 5, everywhere there's an n, I'm going to put 5, right? So here I have f of 4 plus 9. Well, what's f of 4? Let's go back up here to our list. This is the first term. This is the second. Third, this is the 4th. So f of 4 is simply the 4th term. So f of 4 is 29. 29 plus 9, which is going to equal 38. So the 5th term is 38. Let's go look and see. If I were to find the fifth term just doing it the old-fashioned way there, 29 plus 8, oh look, it's 38, and that's the fifth term. If I asked you to find the 100th term using the recursive formula, it would take quite a while, because to find the 100th term, you're going to need to have the 99. To find the 99th, you're going to need the 98. To find the 98th, you're going to need the 97th, and so on. So this formula is not necessarily the quickest way to get there. The other formula, the explicit formula, is the one you're used to using. This may not look like any formula you have ever seen before, but it is one. A sub n, let's start there. Once again, that's just the answer, so that's going to be any of my y values. A sub 1, hopefully you're picking up by now. If n equals 1, because that would be a sub n, right? If n equals 1, well, that's the first term. N is going to be the number of the term, and then d is once again going to be our common difference. Okay? So we're going to use this formula to find the 50th term. So let's see, it goes a sub n equals the first term plus n minus 1 times the common difference. So a sub n, if I'm going to personalize this, well, a sub 1 equals 2. And then d, well, d equals 9. So I have 2 plus n minus 1 times 9. They want me to find the 50th term. The 50th term means n equals 50. So everywhere there's an n, I'm going to put 50. So let's see. Oh, I don't want to write that again. 2 plus, we've got 49 times 9. 50 minus 1 is 49. Then I would do 49 times 9. $441, and then you get $443. So the 50th term is 443. So those are our two arithmetic sequences formulas. One could be a whole lot of work. The other one, you could find any particular term relatively easy. So now let's look at, given this sequence. So this is an arithmetic sequence. If it's arithmetic, that tells me that it's changing by the same thing over and over again. To go from 1 to 300 is 200. To go from 300 to 500 is 200. So the common difference is 200. If I were to write a table for this, the first term is 100, the second is 300, the third is 500, and if I wanted the fourth, well, I would just add 200 to the previous term. This is an example of you using the recursive formula. If I took the previous term 700 and added 200 to it, that would give me 900. Once again, you are just using the recursive formula. Writing these as points, I got 2 300, I got 3 500, and then I got 4 700, and 5 900. Okay? They're telling you this right here is going to be the recursive formula. It looks a little different, but it's still saying the same thing. A sub 1, well, that's going to be the first term, which is 100. Notice this right here is f of n. This right here is just f of n minus 1. Plus, well, what's the d value? 200. So these two things do the exact same thing, they just look a little different. And I need for you to be able to recognize that any time that common difference is being added onto the end, you're talking about the recursive formula. This part right here always says the previous term. So I would recommend, more than likely you prefer the first one we worked with. Whichever one you like better, just make sure you can recognize them. Now they want us to write the explicit formula. Remember, I'm going to need a sub 1 and I'm going to need d. Well, the first term was 100, correct? We wrote that down right here. Then the second term, d, it was changing by 200. So the general explicit formula is a sub n equals a sub 1 plus n minus 1 times d. So I'm just going to plug in the items you need. That would be what? A sub n equals the first term, which is 100, plus n minus 1 times 200. That would be your explicit formula. Now they want you to find the 15th term. You get to choose which formula you want to use. Say you were to choose this one over here, your recursive one. I want you to understand what that entails. I currently have up to the 5th term. For me to find the 15th term, I'm going to need the 14th, the 13th, the 12th, the 11th, the 10th, the 9th, 7th, and so on. So you have a lot of terms you would have to find. Instead of doing all that, I would use the explicit formula. If we were to write the explicit formula, it would look like a sub 15 equals 100. Remember, we're just looking for the 15th term. So this is what it'd look like, and we would simplify it out to where the 15th term would be 2,900. Hopefully you realize we would use this one just because it's simpler. Okay, so now looking, we got a word problem. You're talking about at the IMAX, you have the first row of the movie theater. It has 20 seats in it. Each subsequent row, in other words, the row behind it, the row behind it, the row behind it, they keep adding 2. So the first row, in other words, has 20. A sub 1 is 20. Each row after that would be adding 2, which means D equals 2. To write the explicit formula, it goes A sub n, first term, plus n minus 1 times D. So A sub n equals, well, the first term we said was 20, plus n minus 1 times 2 added per row. Now they're saying, okay, the last row has 58 seats. That means A sub n is 58, okay? Because the number of rows is represented by n. How many seats are represented by A sub n? So I've got 58 equals 20 plus n minus 1 times 2. And now we're just going to simplify it to get n by itself. You may want to start by subtracting 20 from both sides, which would give you 38 equals n minus 1 times 2. Then I need to distribute my 2, which would give me 2n minus 2 equals, I don't know why that looks like an x. That's supposed to be, what's that supposed to be? Oh, a 38. Okay, that's a 30. Hold on, that doesn't look at all like a 38. Let me make that look like a 38. Okay, better? Yes, subtract the 20. Okay, so then I got 38. Now I would add 2 to both sides, giving me 2n equals 40. Divide by 2, and we got n equals 20. So I'm going to have 20 rows in the IMAX. Last thing we have is say I'm given. This right here is a recursive formula, right? This says take the previous term and add 3 to it. So based on that, they want me to write the explicit formula. If you look at the recursive formula, it looks like f sub n equals f sub n minus 1 plus d. Therefore, d equals 3. And then this right here is telling you the first term is 4. So if I write the explicit formula, it would be a sub n equals the first term, which is 4, plus n minus 1, times 3, which is d.